Okay, so this is a key to section 2.1, part 1, and the numbers 1, 2, and 3, and those three relations. Now remember, in these cases, in 1, 2, and 3, each relation is a set of ordered pairs, and you can actually count the number of ordered pairs, so this is a finite set versus infinite. See how over here you have an infinite number of ordered pairs on the graph? So this is an infinite number. This is an infinite number of ordered pairs. This relation here has an infinite number of ordered pairs on the graph. Here, this is a finite set. You can count them. Here, you cannot count how many points are on this graph, this relation. There's an infinite number of it. Okay? All right, so remember a function, though. You can use this definition. A function, remember, is a relation in which for each x-coordinate in the domain, or for each element in the domain, there's exactly one element in the range. So for each x, there's got to be exactly one y. So if we consider these x and y coordinates, and in this course, you'll notice that the x-axis and y-axis are always x and y. Sometimes, though, they could use different variables, but in this course, you can think of this as x and y coordinates. So remember the function is relation in which for each element in the domain, there's exactly one element in the range assigned to it. So when talking about whether each of these is a function or not, it's helpful if you use a mapping for these. So let's call um, this the x or the domain, and this would be y or the range, so the domain and range. Now basically what you're going to do is that for each element in the domain, you're going to list it here, and you're going to assign to it whatever the y coordinate is from the range. So for example, when x is 1, it gets assigned the y value of -2. All right, so here's your domain, and this is the elements from the range. When x is -3, it gets assigned, notice the rate coming from it, it gets assigned to 5. When x is 0, it gets assigned to 1. When x is 4, it gets assigned to -3. Alright, so by definition, look at this. For each x coordinate, so for example, when x is 1, what is the y value? Well, the y value is -2. There's nothing else assigned to it. When x is -3, the y value is 5. There's no other y value assigned to it. When x is 0, there's only one y value. It is 1. There's no other y value assigned to it. When x is 4, there's only one y value, -3. There's no other y value assigned to it. So by definition of function, for each element in the domain, there's exactly one element in the range assigned to it. So that's a function. So the answer is yes there. And remember, the domain is just, since this is a finite set, you have a finite number of elements in the range and the domain. And so your domain, you just list your x coordinates and just list it. Let's just go ahead and list them in numerical order. If you did not, it's no big deal. But let's go ahead and mathematically put them in numerical order. So my domain would be the elements consisting of 1, -3, 0, and 4. Now just keep in mind, if it occurs more than once, you only list it once. Only list the element once. So 1, -3, 0, and 4. So we'll put -3 first, then we'll put 0 next, and then 1, and then 4. So those are the elements from my domain. 1, -3, 0, and 4. The range, you have -2, 5, 1, and -3. So -2, 5, 1, and -3. So you just list them also. And let's just go ahead and put them in numerical order. So -3, -2, 1, and 5. Alright, now it's also keep in mind that you must use a brace to denote a set. Don't put this in parentheses. That is mathematically not correct. You must put this as a set to denote, a brace to denote a set. Alright, now do the best you can with drawing this brace. Look something like this. Okay? Alright, now over here, again, let's do the same thing. I'm going to list the elements in the domain. I'm going to list the elements in the range. Now again, if it occurs more than once, you only list it once. Make sure you only list it once if you're using this so you can help yourself. When x is -2, the y value assigned to it is -1. 1. Okay, so you just do this, just draw an arrow, a ray, and then you say negative 1. When x is 0, the y value is 3. When x is 4, the y value is 4. Okay? So notice for each x coordinate, there's exactly one y coordinate. But remember, you got to check everything that's in the relation. When x is negative 2, now notice negative 2 is already listed, so don't list it again, because if you do, you're probably going to get the answer wrong. So list it once. List it once. So negative 2 is already listed. So I'm going to go, and 3 is already listed for y, so I'm just going to say this. Okay? So notice that when x is negative 2, in the end, after looking at all of this, when x is negative 2, that's our issue. When x is negative 2, there are two different y values. When x is negative 2, I get a y value of negative 1, and I get a y value of 3. The definition function says that when x is negative 2, there should only be one y value, not 2 or more. There should only be one y value. And since when x is negative 2, there are two different y values, this is not a function. All right, so it's not a function since x equals negative 2 has more than one y value. One y value. So that's one y value. Okay? All right. Now let's list the domain and range. And again, only listed once. And if you did what we just said, listed only once here, then you can just get it from here. So my domain would be negative 2, 0, 4. Negative 2, 0, 4. And my range would be negative 1, 3, 4. Just go ahead and put them in numerical order. Negative 1, 3, 4. All right, so this relation has 3 elements in the domain and 3 elements in the range. It is not a function because when x is negative 2, notice there were two different y values, negative 1 and 3. Definition says there can only be one y value. All right, the next one, let's do the same thing. Let's do x, the domain, and the range. So when x is negative 1, I get a y value of 5. When x is 0, I get a y value of 3. Again, only list it once as you write them. When x is 2, I get a y value of 3. It's already listed, so just draw an arrow to it. Don't list it again. Do not list it again. When x is 3, I get a y value of negative 1. All right. Now, some students will say that this is not a function because they look at this and they look at that y value and they see there are two arrows coming to it. That's okay. The definition of function says that for each x, there has to be just one y value. So you can have a y value occurring for more than one x coordinate. So all these could be 3's. All these could be 3's. It does not matter. As long as for each x coordinate, there's just one y value. So in other words, when x is negative 1, my y value is 5. There was no other y value assigned to it. When x is 0, the y value is 3. There's no other y value assigned to 0. When x is 2, the y value is 3. There's no other y value assigned to the x value, the element of 2. When the x coordinate is 3, there's only one y value attached to it, negative 1. There's no other y value assigned when x is 3. All right, so this is a function. And again, you list your domain and range. Make sure you use set notation, something like this, and just use this. Just list what you see here, because that's where they came from. So negative 1, 0, 2, and 3. Negative 1, 0, 2, and 3. And then the range would be negative 1, 3, 5. So negative 1, 3, 5. Okay. Now, over here, so notice that this relation was indicated as a set of ordered pairs. Here, these relations are represented as graphs. Now remember, these are still relations because remember the definition of relation says a relation is a set of ordered pairs. Well, all these are ordered pairs. Every point on the graph is an ordered pair. It's an x and y coordinate. This point's an x and y coordinate. This point's an x and y coordinate, and so on. Okay. Now here they were finite. number. So there were only 4 points here. There were, well, I guess 4 points in each one of these. Here there's an infinite number of points on this graph. There's an infinite number of points on this graph. All right, infinite number of points on this graph. All right. So, so when a relation though is represented as a graph, we're going to use, remember, the vertical line test. And the vertical line test comes from the definition of a function. And so, for example, if I look at this vertical line, let me see. Let me go ahead and use this red pen. If I look at this vertical line right here, right away, you know it's not a function. It fails a vertical line test. The vertical line test says this. And I'm going to use this one. Vertical line says that no matter where you draw a vertical line on the graph, you got to look everywhere. No matter where you draw a vertical line on the graph, it will intersect it just once each time. So notice that this vertical line, each vertical line here, intersect the graph just once each time. Once each time. Okay, here, 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 and here, and so on. So there's an infinite number of these vertical lines. All right, now make sure you understand why it applies to the definition. Okay, so for example, see this point here, and we just said that this red line intersected the graph just once. Well, that means this: when x is -2, that was only one y value assigned to -2. It was this y value here, whatever it is. I guess 3. All right. When over here, when right here, when x is -1, when x is -1, there was only one y value assigned to it. I guess it's 2 in this case, and so on. Okay. Over here, though, notice that it fails a vertical line test because the vertical line test says that the graph must cross. I'm sorry, the vertical line. Every vertical line must cross the graph just once each time. And so there are an infinite number of places where it fails. But let's just look at this one right here to make sure we understand why it works with the definition of function. So when x is 2, let's just think about this. When x is 2, what are the y values? Well, look at this point here, and look at this point here. So there are 2 points in the graph where x is 2. Make sure you see this. X is 2 here, and x is 2 here. Okay? What is this y value right here? Well, that y value is 2, and this y value is a -2. So notice that when x is 2, there were 2 y values, 2 and -2. All right, so since the vertical line crossed the graph twice here, that means that if I were to use this mapping, when x is -2, I get a y value of 2, and I get a y value of -2. So notice there are 2 rays extending from this x coordinate. All right, so no matter where you draw this vertical line, the vertical line test is going to intersect the graph twice except here. So here it only intersected once, but everywhere else it intersects it more than once. Okay, so this is not a function because it fails the vertical line test. Fails the vertical line test. Okay, here this is a function because it. So I'm going to say yes because it passes the vertical line test. And the same thing here, when you draw and remember this thing keeps on going and keeps on going here. When you draw the vertical line, it intersects the graph once each time. So that means that for each of these x coordinates, there's just one y value assigned to it. So this is a function, so it passes the vertical line test. Okay. All right, now another way to represent a relation is from an equation. Now, just be aware that if you know what the equation looks like, then you can, in your mind, visualize using a vertical line test. So, for example, in number 7, right here, in number 7, we have y minus 2x equal 3. Now, for students, when determined if an equation represents a function, they want to sometimes get y by itself, which is a good idea. So if you get y by itself, you're going to add 2x to both sides. And so when you do that, you get y equals, that's it, 2x. So y equals 2x plus 3. Okay? Now, from here, you can go two separate directions. You had experience graphing this from previous courses and even from this course. So this graph here, y equals 2x plus 3, you have to recognize that this is a linear function. Or linear, let's just say linear equation for right now. That's a linear equation. All right? So it's linear. So y to the first, x to the first. Okay? So you know also that the graph here, that the graph is a straight line. Okay, it's linear, so it's a line. So the graph is a straight line. It has positive slope. That's positive slope. And the y-intercept is 3. So since it's positive slope, you know it's gonna probably do something like this. And so it's gonna pass the vertical line test. So if you know what the graph looks like, you can visualize it. All right, now if you don't know what the graph looks like, then here's the way you would do this. Okay, so that's using so it's a function. Yes, it is a function. All right, and then remember, there was no explanation here, but if you were asked to do an explanation, then this would be your work. So you showed that this is a function by graphing it, and so this is a function. I graph the line, and it passes the vertical line test. Okay, so that's one way of showing that this is a function, or explaining that this is a function. Now the other way is this. So let's go ahead and rewrite this. So that's y equals 2x plus 3. The other way is just use a t-table. Just use a t-table. So for example, give some numbers for x. So if x is 0, y would be 2 times 0 plus 3, because remember, where we see the variable x, you plug in 0. So that's 0 plus 3, which is 3. And so notice that when x is 0, there's only one y value. So far we are okay. But you gotta use a few more points. Now notice you can't use all the points because there's an infinite number of points on this line. So there's no way you can list all of them. So just do a few positive, a few negative, and see if for each x value you get exactly one y value. Okay? So in order for it to be a function, for each x, there's got to be exactly one y assigned to it. So when x is 1, I get y equals 2 times 1 plus 3. So 2x plus 3, so x is 1. So that's 2 plus 3, which is 5. So for this x coordinate, there's only one y coordinate. When x is 2, I get y equals 2 times 2 plus 3. So that's 4 plus 3, which is 7. All right, I'll do a couple of negatives. So let's say negative 1. I get y equals 2 times negative 1 plus 3. So that's negative 2 plus 3, which is 1. All right, so for this x coordinate, there's only one y coordinate. And then, now keep in mind that you can use decimals if you want to. We're just using integers here. But you could say 1.3, 1.276, negative 1.88889 if you want to. All right? But we tend to just deal with just integers. When x is negative 2, I get y equals 2 times negative 2 plus 3. So it's negative 4 plus 3, which is negative 1. So notice that for each of these x coordinates, there's just one y value. All right, so this is a function. So this is a function. Now, when we say this is a function, I mean the original was y minus 2x equal 3. So that is a function. Okay, so that will be your explanation. So if there was anything that said explain or show your work, then this would be it. You would show something like this. So this is a function for each x coordinate. There is exactly one y coordinate. Okay. All right. So that one is yes. All right. Now, number 8. Let's look at number 8. Okay, so let's see. All right, number 8. You have y squared plus x squared equal 4. Y squared plus x squared equal 4. Now again, just like before, if you know what the graph looks like, and we did this already, so if you know what the graph looks like, remember x squared plus y squared equal 4, just rewriting it, notice that this is the equation of a circle. That's the equation of a circle. And so right away, in your mind, you see the circle. Well, right away, you know that a circle is not a function because it fails the vertical line test. All right, so if this were in a coordinate plane, for each x coordinate, if this was in a coordinate plane, for each x coordinate, there is 2 y coordinates, except for the ends here, the endpoints. All right, but everywhere else, it fails the vertical line test. So that would be one of your explanations. You could say, well, this is a circle. It has center, and I drew this wrong, but the center, if I actually did this, the center would be 0, 0, if you did it, and the radius is 2. 1, 2, 1, 2, 1, 2, 1, 2. So that would actually be the circle. All right, but again, it still fails the vertical line test. So that would be your explanation. Now, if you did not remember that this was the equation of a circle, then what you do, just like we did before, where we got y by itself, you get y by itself. So when I get y by itself, when I get y by itself, so I get y squared plus x squared equal 4. So when I get y by itself, I'm going to subtract x squared from both sides. All right, so I'm going to get y squared equal 4 minus x squared. And then remember, to get y by itself, you can take the square root of both sides now. So I'm going to go ahead and rewrite this here. So y squared equal 4 minus x squared. Square root, square root. But remember, when you take the even root of both sides of the equation, you got to use plus or minus. So the square and the square root into each other, so you get y equal plus or minus the square root of 4 minus x squared. Okay? All right. Now, let's use a t-table just like we did this. Remember when we did the previous one? When I got y by itself, I use a t-table. So use a t-table. So here's the situation. When x is 0, write it out. Now don't forget, this is plus and minus. If you let the plus and minus off, you'd probably get this answer wrong. So y equals plus or minus the square root of 4 minus x is 0, squared. So that's plus or minus the square root of 0 squared is 0. 4 minus 0 is 4. So that's plus or minus 2. So look at what that says. That says right here that if I use this again, that when x is 0, I get a y value of 2, and I get a y value of negative 2. So notice that when x is 0, there's more than one y value assigned to it. So right away, it's not a function. It's not a function. All right, so that will be your explanation if you were asked to show an explanation. But in this, you did not have to. But this is what you had to think about. Either this, knowing it's a circle. If you did not know it's a circle, get y by itself. You get plus or minus, and then you use a t-table. So this is not a function. Okay, and I'm going to make a note here that that's a circle. Okay, now over here in number 9, you got to remember something from last semester, that this is the graph of an absolute value. So if you know what the graph looks like, you have y equals absolute value of x plus 2. So the graph looks like this. So you can get a vertex at negative 2, and then, let's see, you get something like this. All right, but you didn't have to draw it per se. You could have in your mind visualized that the graph of an absolute value relation. Let's call this a relation for right now. The graph of an absolute value relation is the shape of that V. All right, so that's that V. So right away you can see that it passes the vertical line test for each for each x coordinate, there's only one y value assigned to it. Okay. Um, so so if you did not recognize, so this is a function. So if you did not recognize, when I say this, I mean y equals absolute value of x plus 2 is a function. That's what I mean. So if you did not recognize that this graph was this, then you do the t-table. Okay, so y equals absolute value of x plus 2. And so when x is, let's say, 0, when x is 0, I get a y value of, okay, so x is 0, so I get 0 plus 2 absolute value. So that's absolute value of 2, which is 2. So I get a y value of 2. So notice that when x is 0, there's only one y value. Y value is 2. When x is, let's say, 3, I get y equals absolute value of 3 plus 2, which is absolute value of 5, which is just 5. Okay. When x is, let's say, 0, oops, we already did 0. When x is, let's say, negative, let's do some negatives. Well, let's do one more positive. Let's say 1. When x is 1, I get y equals absolute value of 1 plus 2, which is absolute value of 3, which is 3. Okay. When x is, let's say, negative 1, I get y equals absolute value of negative 1 plus 2, which is absolute value of 1, which is 1. So notice that for each x coordinate, there's exactly one y coordinate. And let's do one more. Let's say negative 2. When x is negative 2, I get y equals absolute value of negative 2 plus 2, which is absolute value of 0, which is just 0. All right, so notice that for each x coordinate, there's exactly one y coordinate. So notice when x is 0, it's just 2. I didn't see anything else assigned to 0 for y. So when x is 3, there's only one y value assigned to it, and it is 5. When x is 1, there's only one y value assigned to it. Okay? Now look, if you put, let's say, negative 4, just to show you, let's say use negative 4, y equals absolute value of negative 4 plus 2, which is absolute value of negative 2, which is just 2. Don't let this and this confuse you. You remember, it is okay for the y value to occur more than once. You got to look at the x values. The x values can only occur more than once. I'm sorry, the x value can only occur once and be assigned to each y, to exactly one y coordinate. So right here, if you see the things I have circled, it is okay to have these y values with these x values with the same y value. So look at that t-table. The mapping. When x is 0, I get a y coordinate of 2. When x is negative 4, I get a y coordinate of 2. All right? So it's okay. For this x coordinate, what's the y value? It is 2 and only 2. When for this x coordinate, what's the y value? It is 2 and only 2. So this is a function. I'm going to say this. Y equals absolute value of x plus 2 is a function. All right, so that one's yes. Okay, now when you do number 10, notice that in each of these cases, 7, 8, and 9, we got y by itself. Okay. Now, here we knew this was a line. We knew this had the shape of a V. We knew that this was a circle, but this you don't know what that looks like. Okay, you have no idea what that looks like. You didn't graph anything like this last semester or the semester before that. Now you may, in your mind, based on your experience from previous math courses in high school maybe, you may be able to see what this looks like. But if you don't, then get y by itself. That's the best thing to do here. Get y by itself. So I have y squared equal x plus 1. And so when I get y by itself, remember I'm squaring right now, so the opposite is just take the square root. And so the square and the square root undo each other, so you get y equals plus or minus, don't forget the plus or minus, if you do, you're going to get this wrong, plus or minus the square root of x plus 1. So what that means is this, use a t-table now. When x is 0, let's find out what the y coordinate is. Well, the y coordinate would be plus or minus the square root of 0 plus 1, which is plus or minus the square root of 1, which is plus or minus 1. That's what y is. Now notice what that means when you do this mapping. When x is 0, you get a y value of 1, and you also get a y value of negative 1. So it fails the definition of function. For each x coordinate, remember there must be exactly one y coordinate. Well, that's not true here. When x is 0, there is two different y coordinates. And the same thing would have been true if you let x be, let's say, 1. So I get y equals the square root plus or minus the square root of 1 plus 1, which is plus or minus the square root of 2. So again, when x is 1, there are two different y values, the square root of 2 and negative square root of 2. Alright, now just keep in mind that I cannot use negative, I cannot, let's do negative 1. When x is negative 1, notice what happens, get y equals plus or minus the square root of negative 1 plus 1, which is plus or minus the square root of 0, which is plus or minus 0, which is 0. So notice that when x is negative 1, there's only one y value. But the reason it's not a function, is because for the other points, when x is 0, there are two different y values. When x is 1, there are two different y values. When x is 2, there are two different y values, and so on. Now, I wanted to make a note here. In terms of the numbers that you can use, negative 1 is going to be the smallest x coordinate. See, negative 2, if you plug in negative 2, you're going to get y equals plus or minus the square root of negative 2 plus 1, which is plus or minus the square of negative 1, and that is not a real number. Okay, that is not a real number. So when x is negative 2, there is no y value. The y value does not exist. So just be careful, basically just be careful that sometimes when we use a t-table, here there's an infinite number of, I can use any real number. So here my domain would be any real number. Here, the one we did earlier, if I can find it. And again, here I can't use just any real number. We didn't talk about this because the domain here, remember the domain goes from negative 2 to 2. So anything outside of that domain I can't use. So just be aware that for this one, some of you may have done negative 2 and you would have been confused because if you put this in your calculator, it'll say domain error or does not exist. All right, and that's because when you graph it, if you actually just graph this, and you don't know what this graph looks like, but if you did graph it, it will look something like this. And you see it starts at, oops, wrong. Yep, wrong one, sorry. When you graph it, it'll look like this. Alright, so start at negative 1 all the way to infinity. That's your domain. But notice it fails the vertical line test. Okay, so for this x coordinate, there are two y coordinates. For this x coordinate, there are two y coordinates. For this x coordinate, there are two y coordinates. Okay, for this x coordinate, there's only one. It is 0. We talked about that. All right, so some of these are challenging. Go back and review this. So basically, this is not a function. So not a function. And that would be your explanation. So you get y by itself, do a t-table. You could have stopped here right away. Just say when x is 0, plus or minus 1, done, not a function. All right, I did this other stuff just to show you some information, a little bit more information about this. So, not a function. Okay, now, for number 11, you see how, now here in 8 and 10, you could have easily gotten y by itself. Okay, it's easy to get y by itself. Here, it is not. Go ahead and leave 11 by itself. You don't know how to, it's a little bit difficult here to solve for y. because of the way it looks. So it's doable. You can solve for y. You got to remember something about absolute value equation. All right, and so it's a little bit difficult when this is not a number on the other side. So what I want to do here for number 11 is do it this way first. So in number 11, you have x equal the absolute value of y. All right, now notice x is by itself, not y, because it's absolute value of y, but I have x by itself. Okay, so I'm going to use a t-table. And since x is by itself, I'm going to substitute numbers for y. So if y is 0, I get x equals the absolute value of 0, but that's y here, which is 0. So notice for this x coordinate, there's only one y value. Okay, now let's do another value for y. When x is 1, I get x equal the absolute value of 1, which is 1. So my x coordinate is 1. So notice so far, when x is 1, there's only one y value. Now let's do negative 1 for y. When x is negative 1, when y is negative 1, I get x equal the absolute value of negative 1, which is 1. Okay, now this is where you can stop. When x is 1, how many y values did you get? When x is 1, there was a y value of 1, and there was a y value of negative 1. So right away, you can stop and say this is not a function. So that's not a function. All right. Now the graph would look something like this. You don't know what it looks like. You don't know how I'm getting this, but that's the graph. And so right away you can see that it fails the vertical line test. Okay. All right. And then number 12. So that one is no, not a function. Now I said right, yes or no. So you should say no for each of those. No, no, no. All right. Now this one. So y equals x squared minus 1. Okay, so you may remember from last semester that this is the graph of a quadratic. And remember y equals x squared is quadratic. The negative 1 shifts it down 1. So the graph, look at the graph, it looks something like this. So you have this parabola. And so from the graph, you can tell that it passes a vertical line test. So right away, if you remember what the graph looks like, you can say that it passes a vertical line test. Draw the graph. Make sure you show this. And so it's a function. So y equal x squared minus 1 is a function. Okay. Now, if you did not know that this graph looked like that, just use a t-table, and then pick some numbers for x's and see if for each x you get one y value. Okay. So for example, if x is 0, let's see what we get. Y equals 0 squared minus 1. So wherever we see the variable x, I plug in 0. 0 squared, 0, 0 minus 1 is a negative 1. So notice that for this x coordinate, there's only one y coordinate. When x is, let's say, 1, I get y equals 1 squared minus 1. 1 squared is 1. 1 minus 1 is 0. So notice that for this x coordinate, there's only one y coordinate. Keep on going, though. Don't stop there. When x is, let's say, 2, I get y equals 2 squared minus 1, which is 4 minus 1, which is 3. So for this x coordinate, there's only one y coordinate. When x is, let's say, negative 2, let's do negative 1. Let's do negative 2. Negative 2. When x is negative 2, I get y equals negative 2 squared, in parentheses, minus 1. So negative 2 squared is 4. 4 minus 1 is 3. Now again, don't let the fact that 3 occurred twice for a y value throw you off. That's okay, as long as that for each x coordinate, notice what happens. For each x coordinate, let's do the 2 negative 2. There's only one y coordinate. So notice that when x is 2, y is 3. When x is negative 2, y is 3. It's okay for these x coordinates to have the same y value. All right, and if you keep on going, you'll see that for each x coordinate, there's only one y coordinate. So this is a function. So y equal x squared minus 1 is a function. So I'm going to say yes here. All right, so Given the set of ordered pairs and given the graphs, it's very easy to determine this information that's asked for. Here, it's a little bit more challenging for students, especially if they don't know what the graph looks like. Like this, you knew that was a line, that was a circle, that was absolute value, so that's a V. That you did not know, you did not know. That you probably knew, that was a parabola. And if you did not know any of what the graphs look like, you just use a t-table. This was the most challenging right here, though. And for these two, remember what you had to do, you had to get y by itself. So at some point, you had to take the square root of both sides and do the plus or minus. So that plus or minus is what gives it away. That plus or minus, see when I did the plus or minus here, I'll just show you. When I did that plus or minus, that means that for that x value, there's going to be two different y values, a plus square root and a negative square root. So that gives it away. That's going to make it not a function. All right, so that's why you see when x was 1 here, you got 2 as the radicand, so square root of 2. So you got a positive square root of 2 and a negative. Positive square root, negative square root. So right away, when you see this, if you draw this, then you know it's not a function. But then you would kind of give an example. Well, you would say when x is 0, I get plus or minus 1. And so give an example of an x value that doesn't work. Okay? All right, so this worksheet's a little challenging for students, but do the best you can with understanding what a function is, how to determine in all three different situations if a relation is a function. Okay, so that's going to end this.